channel, and today in this tutorial we are going to learn how to perform a t-test for independent samples, unpaired samples for t-test, samples which have unequal variance. We have a null hypothesis. Null hypothesis, no difference in the mean of a population or a group, and alternative hypothesis says there is a difference in the mean of a population group. And alpha value is 0.05. We are going to use here a library tidyverse and the library Deuterium. Deuterium you can download from the friend package, and it's a really good library. It has some data sets where we want to perform today's t-test. So we have here, and I run this library. We have it in the Deuterium library. We have a data set called gender weight. I make one vector called GWT, like a gender weight, and I run this here. So it asking no thanks, I don't want. So we got a vector called GWT. We can see this vector by running GWT here, and as we click, so we can see here we have IDs, we have a group contains male and female data, and body weight. So we have here two data, so we are going to perform like a t-test on it. So first we have to make two data sets, one for the male and one for the female. We say GWT, and we say use a pipe function. We are going to use a pipe function from the tidyverse library, and we say here, right here, filter, and what the gonna be filter, we going to filter a group that is equals to logically equals to female, and this when is equal, so what we do, we make one subset of the data called GWT underscore F for the female, and the same we gonna to repeat for the male, and we just make a little difference. At the place of F we just write an M, and in the end also we write the M, and yes, we just run this code of chunk. We got our two data sets. We can GWT underscore F. If I write and run, so we can see we got one full data set for the female, and if we just change here from F to M and run, we can see we got the data for the male. So now we have two data set, one for the female and one for the male, and on these both data set we can perform Shapiro test to check the normal distribution. So what we do here, we would just write here, and so we write here the markdown. In the markdown we write this and say okay. So now we're gonna to perform a Shapiro test on our both the data sets of male and female to check the normal distribution, whether our data is normally distributed or not before performing the t-test. This is the first requirement. So let's do a Shapiro test, and here we just write very simple GWT underscore F and $sign, and what we want a weight. This is for the female, and we just copy the same, and we have to change only here our data set from F to M male, and we comes and we run this code of chunk, and we'll see, as we see here, our p value for the Shapiro will test is greater than 0.05 in both the cases of male and female data set. It's very clear here with the Shapiro test that data is normally distributed by making a distribution plot. So how we going to make a distribution plot? We just put here another code of chunk, and we write plot density, open the bracket, and in the bracket we're gonna to write GWT underscore F $sign weight. This is the plot gonna be for female. If we run here like this, we can see we have really nice curve, and seems like let's check the mean of this data where it comes. So we put one app line on it where v equals to mean, and where on the GWT underscore F $sign weight, on this we are putting one app line. And what is the color of the app line? Of course we need some color, so we just write a call equals to, we just give the color red. That's, I think it will be very good, and we just run for the, as we see the mean value, the peak of the distribution curve on the left side. So we can say here the data going on the left side, and the peak is say about the kurtosis. So peak is like a really little high end steep. So kurtosis seems good, but its data is a little bit on the right side is skewed here. And the same we perform on the male data set. I will just copy here and put another code of chunk. We paste here, and here this time we just need change from F to M male data set, and here also the male data set, and we check the distribution of a male data set how it is, and we run the code of chunk here, and as we can see the male data set is really have a very nice distribution, and the mean also completely in the center of the P. So like this, we can check that data is normally distributed with the help of distribution plot. So now I would like to check inequality of variance, because that establish if the variance are equal, we use one set of formula. But if the variance is not equal, we use slightly different set of formula to calculate the t statistic. At this point, I like to check variance of my both the data sets, how it is before performing the t-test. So I want to establish using the function in the test. So here we put in a one code of chunk, and I can in the markdown I can write check the variance for the data, and we just click here, right? So here we have checked the variance. We use the function called var.test, and here in this test we just write our data set gwt underscore f dollar sign, we choose from here weight, comma, and gwt underscore m dollar sign weight. And this code will gonna give us a full information about how is our data really have equal variance or have not equal variance. So we just run our code and we get the F test to compare two variants, and here is saying is giving us an F value and number of freedom, degree of freedom for our samples, and important thing is a p value. And here as you can see, p value in this case is 0.001. It's really less than the 0.05. So our variants are not equal. We can reject the null hypothesis at this point. So we know our data is normally distributed and our variants are not equal. That gives us a useful information to perform the test. So now we here comes and put a one markdown, and we write here perform the t-test for normal distributed data with unequal variance, and we just click here. So this is our task, and for this we gonna to use some parameters to perform the t-task. So let's write here t.task, open the bracket, and here we gonna give our data gwt underscore f dollar sign weight, comma, gwt underscore m dollar sign weight. This is our data, and we write the comma here and we'll make given the one enter. And now we says alternative equals to, because our data is normally distributed, it have a both sides the two tails. So we write here 2.sided and give a comma, and we say paired equals to false. And important thing is variance dot equal, we have to give here false, because our data is not really don't have an equal variance. So we write here variance dot equals to false, and these were our important parameters here. And we just run the test here, and as we run the test, it gives us output is a Welch 2 sample test. Here we get some t statistics, that is a -20, degree of freedom is a 26, and p value is really important, is really less than 0.05. So at this point our null hypothesis is rejected because our p value is highly significant. So we have sufficient evidence to reject the null hypothesis, and so we found a significant difference at the, as we can see here, at the 95% confidence interval between the man and woman body weight. There are significant differences, and these two values -24 and -20 will lies between the 95% confidence interval. Similarly, we can see the mean of x and y. There is a significant difference in the body weight of both the groups. So these output values are important to write the output of the t-test. So that's how you perform the t-test for the independent samples unpaired with the unequal variance. I hope you found this video useful. Please consider to subscribe and hit the like button and click the bell icon for further notification.